we have AP calculus AB problem. Okay, let's go with the information. Given f of x equals to 2x negative 3 if x less than or equal to 2 and f of x equals to x square negative 1 when x is greater than 2, evaluate the limits. We have to evaluate three limits. One is limit x approaches 2 from its left side f of x, and the second one is part B, that is limit x approaches 2 from its right side f of x, and the third one is limit x approaches to f of x. Okay, in part A, we have a negative sign on the right side top corner of 2. This indicates x approaches 2 from its left side. So this is called left side limit of 2. And here, when it comes to the limit in part B, so we have a positive sign over here on the right side top corner of 2. It indicates x approaches 2 from its right side. Okay, the third one is ordinary limit. Okay, now let me draw a number line for the values of x. Let me do it over here. Okay, so now let me mark number 2 over here. When x approaches 2 from its left side, all the values over here will be less than 2. That is, in this interval, the value of x will be less than 2. So now let me evaluate the limit we have in part A, that is limit x approaches to negative f of x. As I said already, the negative sign over here indicates x approaches 2 from its left side. When x approaches 2 from its left side, all the values of x will be less than 2. Now we have to consider the piece of f of x where x is less than 2. So this is the piece. I mean, the 2x negative 3 is the stuff we have for f of x when x is less than 2. So we have to plug in this 2x negative 3 for f of x over here. Then I'm getting limit x approaches to negative 2x negative 3. Actually, the negative sign over here indicates that x approaches 2 from its left side. Otherwise, this negative sign has nothing to do with the calculation part. Now, what we have to do is we have to plug in the given limit 2 for x over here. When I do so, I'm getting 2 times 2 negative 3. So then 4 negative 3, which is equal to 1. Okay, now I have evaluated the limit in part A. So its evaluation is just 1. Okay, now let me evaluate the limit we have in part B. That is limit x approaches to positive f of x. Here the positive sign indicates that x approaches 2 from its right side. When x approaches 2 from its right side, all the values over here are greater than 2. That is, when x takes a value in this interval will be greater than 2. Now we have to consider the piece of f of x where x is greater than 2. So this is the piece we have for f of x when x is greater than 2. Now we have to plug in this x square negative 1 for this f of x over here. Then I'm getting limit x approaches to positive x square negative 1. So this positive sign has nothing to do with the calculation part. It indicates that x approaches 2 from its right side. Okay, now what we can do is we can plug in the given limit. That is, we have to plug in this limit 2 for x over here. Then I'm getting 2 square negative 1, which is equal to the evaluation of 2 square is 4. 4 negative 1 is 3. Okay, I have evaluated the limit we have in part B. Its evaluation is 3. Okay, now we have to evaluate the limit in part C, that is limit x approaches to f of x. Okay, here we don't have to do any additional work for this one. So because already we have evaluated the left side limit of x approaches to in part A, the right side limit of x approaches to in part B. So here also the limit of x is the same too. So since already we already know the evaluation of the left side limit of 2, right side limit of 2, from the left side limit and right side limit, you will be able to evaluate the ordinary limit of x approaches to f of x. Let me write the stuff over here. Limit x approaches to f of x. So whenever I want the ordinary limit of x approaches some value exists, so the left side limit of these two and the right side limit of these two must be finite, and also they must be equal. So the left side limit of x approaches to f of x is 1. It's a finite value. The right side limit of x approaches to f of x is also a finite value. But the left side limit and right side limit are not equal. Since they are not equal, the ordinary limit of x approaches to f of x does not exist. So the result for part C is does not exist. So we can write it as DNE.